I'm really interested in understanding further how our climate will change moving forward before we get there, hopefully, because that's the point. Give us a warning. I always loved adventures and like going outside and hiking. I definitely never even realized it was an opportunity that I could have a job in until I was in the Department of Geology at Rowan.
It's beautiful.
What really just kind of resonated with me was working with climate, because the past is the key to the present, and today we are experiencing rapid shifts in our climate system, and I'm interested in where that could take us in the future. Dr. Aaron Barth was my undergraduate research advisor, and I was pretty interested in his research the first time I heard about it. We use what's called cosmogenic nuclide exposure dating, and so that essentially is a way for us to find out how long ago a rock surface was exposed to the atmosphere. Ice sheets respond at such large timescales that it's almost impossible to see in human lifetime. But in order to see that transition state, you have to be able to look into the geologic past. We use rocks to interpret past environments, and so we're specifically focused in glacial geology. The Adirondacks represent a more interior component of the Laurentide ice sheet, which was the largest ice sheet during the last glacial maximum. This area is significant because it was fully covered, and then that ice sheet is now gone. We can kind of look at that transition between the two and understand what causes a large ice sheet like that to fully leave an area. We targeted this region with what's called a dipstick study. So basically we're targeting peaks at the varying elevations to try to constrain the ice surface. And what we've found so far is basically that that's almost impossible in that specific location because the ice sheet left so quickly. We go through glacial interglacial cycles throughout the last 2.5 million years or so. The Laurentide ice sheet existed for a lot of that time, and so the fact that it disappeared fully and that it is broadly coincident with an abrupt warming event that happened at the time is really significant to our understanding of what's happening now, because we know that ice sheets are melting and sea level is rising. What we're doing is coming out here and dating the retreat of this ice sheet from this area and trying to understand better how quickly and how intensely ice sheets respond to abrupt warming events. Being the first grad student in the School of Earth and Environment and in the Department of Geology has been awesome. I mean, it's been a great opportunity. My office is this half the time. It's beautiful. It's such an incredible, like, it's my dream. I couldn't have imagined a better career for myself, for sure, and this is just the start.